Welcome from my point of view. This event will be recorded, so it will be then distributed on our project website. And nice to see that it is interesting topic. And my name is Maarit Vehviläinen, and I had a pleasure to work as a project manager in the Stardust project, which is the project hosting this event. And I tell a little bit more about this project. So Stardust project is Horizon 2020 funded EU project, which started in 2017 and lasting now 78 months. We got the extension time for a year and a half, and total EU funding is 18 million. And we have altogether over 30 or about 30 organizations from 9 different countries. In addition to Tampere, there is 2 other lighthouse cities, Pamplona from Spain and Trento from Italy. And the objectives in this project are energy efficiency solutions for that, and also decreasing the carbon dioxide levels in the cities. And these are done, big part of those with the, different kind of IT solutions. And today we hear about digital twins, and why should cities be interested on those? We hear digital twins in general, city aspects, and then we hear 3 examples developed by the help of Stardust project of the digital twins. And questions you can ask with the chat, and there will be our experts will be available for these questions during the whole event, but in case we have time after each presentation, I will ask a couple of those also in this live event. And I will give now the floor to our first speaker. Here you can see the agenda for today. And first we hear what are the digital twins and in what ways could cities take advantage of them. And our first speaker is Jarkko Siréni, who is chair of City Group in Building Smart Finland. So please, Jarkko, the floor is yours.
Thank you very much. I will share my screen so you can see my presentation. So I hope everybody can see. So my name is Jarkko Siréni and I'm acting in the Building Smart Finland actively. I'm chair of the City Industry Group. City Industry Group is a group in Building Smart Finland which thinks about information management and information modeling in city perspective. So basically the image on the right kind of tells what kind of things we are discussing in the City Group. Building Smart Finland as organization is a BIM standardization organization in Finland. So we are developing BIM workflows, BIM guidelines, BIM standards for built environment, containing buildings, infrastructure, and cities. So if anybody of you are interested in developing this BIM, which means building information modeling, please check Building Smart Finland web pages. And the example images here are from a solution called XD Tween. That is my own company who is developing this kind of digital twin platform for built environment. But the presentation is general ideas about what are digital twins and what they can be used for. So a definition of digital twin. There are many definitions for digital twin, but maybe the best one and most official one is defined by the Digital Twin Consortium, which is a global organization developing digital twins in different industry areas. And they define digital twin as a virtual representation of real-world entities and processes, synchronized at specific frequency and fidelity. So basically, this means that we have a digital representation of the real world in digital format. So, and the outcome out of this is that we can simulate, analyze, and optimize the real world events, real world processes, real world elements using the digital twin before we do anything actual in the actual world. So it's kind of a optimization and decision-making way and simulation method for optimizing the real world. There is a link where you can see these definitions. And for built environment, when we are talking about cities and environment where we have a lot of different elements, we have a lot of digital data in different levels, starting from national level. For example, in Finland, Finnish Mapping Agency maintains a lot of digital information about Finland and a lot of other also government organizations. On top of that, we have data in regional level. For example, in Helsinki, we have an organization called HSY, which manages regional information covering multiple cities at the same time. Then we have city level information, which has a lot of GIS data and city models and city planning and city development aspects. Then we have area development, which is kind of a project inside the city that you are developing a new city area, different kind of data there. And we go even more details into project level and object level. So we have all this data together as a digital twin of the built environment. And there are two different kind of standards. We have BIM, Building Information Modeling, which defines very accurately structures and their attributes. And then we have GIS, Geographical Information Systems, which defines this kind of map data and also similar elements, but in kind of different ways. And all of this integrates together. There are also different kind of levels where how we can see the digital twin for built environment. If we think about the building information modeling, that is mostly in project level. So you have BIM models of the building, BIM models of the street, pipe networks, or anything that you are going to construct in a project. And the focus is mostly in design and construction phase, and focus is to optimize that phase. We have a city level where we are talking about city information modeling, where we have an information model of the existing city and then also city planning and city development on top of that. So the focus is in city future development. And on top of that, we have this kind of asset information modeling level where we have a database of all the assets, all the elements in the real world in the database, and that can be used for optimizing the daily operation of the city, like how traffic is moving, how energy is used, how the environment is developing, and so on. So all of these levels combined in digital twin. Here are some examples of digital twins. Digital twin of existing is one part that you typically start from the project. You have different kind of city models. On the left, you can see the city model of Tampere, which is this kind of a photogrammetry model produced with area photography or with a drone photogrammetry. These kind of models you can create with drones, for example. On the right is an example of a city information model based on CityGML standard, and that has objects that have attributes, and the model has a hierarchy. So that is kind of more intelligent model of the city. But you can import different kind of survey data. Maybe the city model is updated once a year, but then for the project you can use laser scanning and different kind of survey methods to make much more accurate models of the existing situation. For example, this point cloud has around 300 million points, and the point density is a couple of centimeters. So very, very accurate models. As you can see, all the vegetation and leaves and everything is modeled very accurately. On top of that, we can add different kind of GIS data. GIS data is geographical information that has geometry and attributes and geolocation. So all of this data has geolocation. So any element here knows the location in real world. So we can have different kind of data like map data, area planning data, traffic network data, that can be combined with the city model. There is a city model of Helsinki and Espoo combined together into this kind of regional model. We can have traffic pollution information. This is air quality information. All of this information comes from different sources. The air pollution is coming from the regional actor in Helsinki region, and this is coming from Finnish Meteorological Institute. Then City of Helsinki maintains data. For example, these are protected bird areas, protected vegetation areas, and different kind of protection areas, and also all the information about the existing areas like parks and roads and everything. And all of this information has a lot of attributes. So we have a huge amount of information about the existing, and all of this is combined using the open format standard and APIs. So you don't import and convert data, you just link the data like in internet web network. You just link web pages. In the same way, we are linking the data and combine this into the digital twin. And for the future, we can have a different kind of data of the project. We can have a basic 3D CAD geometrical models. These models, they don't have much information, but when we are talking about BIM models, then you have much more information. You have all the manufacturer material information and volume information and that kind of things in the BIM models. We can have BIM for buildings, BIM for infrastructure. Like you can see, we have all the electrical ventilation and everything for the buildings. Also for infrastructure, we have all the bridge structures, all the road surfaces, underground pipe networks, all the landscaping and everything combined together. So these models are quite detailed models of the project. And on top of that, we can also add different kind of data that is not 3D model data like documents, or we can add also photos and other kind of data. Here are some examples how you can use the digital twin. Once you have the digital twin of existing and digital twin of future combined together, that is kind of a digital twin of existing in the future. You can then use it for basic tools for making this kind of digital twins is the information management tools. You need to manage in good way all of this information. In a complex project like this area planning project, there is a lot of information in all of the life cycle phases, all of the different domains, and everything has to be combined together into one physical model. We can have different information visualization tools, like here is a road project. We visualize, for example, the alignment of the road. That is something that is not a physical element, so we also visualize non-physical elements. It can be other kind of data also. So information visualization is important. Then, of course, the basic viewing of information, that you can view it in different ways. You can cut the models out and look inside the models and turn on and off elements and many easy ways of viewing. And also measuring from the data. This is a measuring coordinates, measuring distances, but it can be all kind of information checking tools. And more examples, once we have the digital twin of existing, that can be used very easily, for example, analyzing the future cityscape or visibility of, for example, here in Helsinki, they were planning these high-rise towers and they are building already these other towers, and there will be a new big bridge. So the cityscape of Helsinki will change a lot. And having this kind of model, you can view it in any direction, any location, and see how the cityscape is developing. So there's no limitation how you can view the model on any places, and you have the whole city in one model. Another way of viewing this is that we have this area plan regulations, area plan maps, and if you design a new building, one thing is that you want to see that the building design fulfill the area plan regulation maps. So you overlay the building model on top of the area plan map and check that it is inside the regulation areas. Of course, then when you have the city model and you have the design model, it's easy to analyze how the design or the project will affect the environment. And this is one example how the shadowing can be analyzed, that how the building will shadow in different times. Also, one important aspect is that we need to manage also the time perspective so that the cities will develop over time, and we need to do that also in the digital twin. So we have to have the fourth dimension, which is time in the digital twin. So you can simulate construction process or city planning process. So how does Tampere look like after 10 or 20 years? You can use it for collaboration inside the project team. You can do different kind of commenting, discussion. You can also manage tasks inside the model and use it for quality management. Here is an example of the building permit process, so that the tasks will go from person to another person and go through this kind of building permit approval process with the checklists. So we ensure that the users will do certain tasks. Also, this kind of brainstorming and sketching, you can use different kind of rapid modeling tools to make simple volumetric models of your ideas. So you can test different ideas. You can have it as a brainstorming meeting and get ideas of the new planning and that kind of things. And everything can be done directly into the 3D city model. And finally, the project, when you are using all of these collaboration tools, you get the real-time situation awareness and reporting of the project. And this is what you can do in the project, internally in the project. You can use digital twins also externally to communicate the project to citizens, to decision makers, stakeholders. You can have different kind of interactive presentations. You can publish these models online, and you can collect different kind of feedback from citizens. You can have different alternative designs and ask feedback from local citizens about that. You can also integrate this into the participation processes and participation platforms, so that it's not only the 3D digital twin, it can be also connected to different kind of interaction platforms. And also on site, you can take the data with you on site and you can see everything around you with augmented reality. There are some example kind of use cases. One use case for this kind of digital twin and building information modeling is the design project coordination. So you manage all the different design disciplines. You have maybe 10 or 20 different designers working together, and everything has to fit together and work together. And this is the only good way that you can combine everything together and optimize and check that there is no conflicts or errors, and this way improve the project. Also, the building permit process, which I already talked about, that you can use it for checking how the building fits to the existing environment, and also use it for getting feedback from neighbors, so that the new building will not too much affect, or the neighbors are happy with the new buildings. You can also use it for area construction coordination, like in this Hiedaranta project, there is construction going on, so they are building already a new tram line. There is architectural planning, there is design of the new parks, public parks, there is a design for roads and streets, and also underground networks, pipe networks, and also area planning at the same time. So this kind of coordination, this is very good tool. and the citizen participation and communication. This is a railroad project in Imatra that we publish this model to the audience, and the audience can give feedback for the project. Also use it for architecture and design competitions. This is not a real case. There is a real case discussion in Helsinki what to do with this harbor area in southern Helsinki, in middle of city. I just make an imaginary test, take the Bilbao Guggenheim Museum and put it here, and fits quite well. And this can be used for comparing alternatives and see how the different proposals fit to the city. If we go into construction, we can also manage the construction site. Construction sites, they are usually using BIM models. This is a bridge renovation project, and there is a BIM model of the bridge, and they are renovating the bridge, but we also have point cloud data around the construction site, and typically the construction sites, they laser scan or take drone photogrammetry maybe every week, so that they can compare what was actually built to what was designed. And also you can use this to plan the construction site arrangement, like here we are planning where the traffic is going when the bridge is constructed in different phases, and also where are the construction site storage areas, parking area for the employees, and that kind of thing. So a lot of things can be done for the construction site management with the digital twin. So basically it's a digital twin of the construction site. One example for maintenance operations phase is that we can bring these BIM models into facility management and also maintenance phase, and we can combine documents into the BIM models. This is an example of how you can bring operation manual of the kitchen equipment into the 3D model. So it's easy to find because the documents are in geolocation. So you just click in place of the object and you get the document open. And this is important if you are using augmented reality. Then you get also documents in the augmented reality view. So when you are on site, you can open your mobile phone and see all the documents around you. So it doesn't need to be 3D data. It can be 2D data, it can be document data, and this way manage the different kind of information. You can use it for education and entertainment. This was a very fast example how we combine the Helsinki city model and GIS data of World War I fortifications. And this can be used with the GPS positioning. You can go walking here on site, and you can use this application with augmented reality or with the GPS map view and see what used to be here, like a historical field trip, which you can do with your children, a family trip during the weekend, for example. These are examples from Helsinki for energy. Helsinki is very good. They have done solar energy calculation, how much solar energy can be produced in Helsinki. They also calculated CO2 emission of the buildings and also what kind of climate change will be, how the climate change will be affecting these buildings. Also the geothermal or geoenergy potential in Helsinki, where you can build these geothermal plants, and also information for each building in the city, what is the energy type they are using and how much energy they are using. So a lot of data about the energy using, and of course the goal here is to be CO2 neutral at some point. And finally, I already talked that all of this data is georeferenced. So in reality, we already have a lot of data around us. We just don't see it. So there are two ways to see it. We can use virtual reality to go inside the data and view the data from inside and look around virtually. This you can do in your office, or you can take mobile phones and go on site, and then you can see the data around you. And the data can be 3D models, BIM models, 2D data, it can be even document data, it can be statistical data, it can be all kinds of data that you can use on site. Just open the mobile phone, and the mobile phone is the window to the data, and then you can easily open documents around you and that so on. And one advancement here is the game engines, that the game engines allow nowadays to bring this digital twin data into game engine. And game engines, they have a lot of tools for different kind of gamification. It has good tools for visualization and interactive applications. And one of the key elements maybe for digital twins is if you open up your data and you give the data to the audience as open data, that makes the audience and businesses and even hobbyists take the game engines and develop different kind of applications on top of that. So combining digital twins and game engines, I think it's one of the future trends that makes it possible for different kind of innovation and innovative applications. This is the Helsinki city model inside Unreal Engine 5. And this is very brand new, and I think this is one of the first city models in Unreal Engine 5, I think. And that was my presentation. Of course, there is a lot of other possibilities for digital twins, and I hope this give you some ideas, and I hope the next presentations will give you more ideas, and I think we have a couple of minutes for questions too.
Yes, thank you, Jarkko. There is actually questions. Regine Werner is asking, have you evaluated how much citizen participation has increased since using digital twins for the public?
Citizen participation is nowadays quite much the 3D models using citizen participation is quite new. So most of the citizen participate platforms are traditional 2D platforms that show pictures and images, but those are very active, especially, for example, in the city of Helsinki, in middle of city, there was a architectural competition and proposal for new buildings. It gets around 6,000 answers and comments. So people are very active, and bringing this 3D digital twin information to that will increase the available information to these people. And we are now piloting and testing this in city of Helsinki, and this 3D is optional to the other methods that are already in use. But I think this will increase, and more we are using this.
Okay. Regine is also continuing. Are a lot of efforts needed to turn the digital twin that is used for the project more user-friendly for the citizen participation process?
Depends on the application you are using for digital twin. I can talk about the XD Twin, which is my company application. The main focus has been the user friendliness. So, for example, the data like this opens in a couple of seconds. The navigation and moving inside the model is same way as normal map and navigation apps. So everybody are already used to use these, and everything has to be intuitive, and also the feedback is very intuitive. So I think they are very user friendly.
Okay. Then basically, would you say it's 100% worth to use digital twins in citizen participation?
I can give you an example that if people don't understand something, they object. And there has been good example. For example, one metro project in Helsinki was delayed 1 year because of objection or complaints. And some of these complaints, they are caused by not enough information. And 1 year delay in 1 billion euro project is quite a lot of money, because the construction cost is 3% increase every year. So giving people information transparently is the key for this kind of citizen participation and successful projects.
Thank you, Jarkko, for
Thank you.
presentation and excellent examples there. Then we go forward, and we have our own Roope or Rodrigo Coloma from city of Tampere, planner in positioning unit, and he will tell about cities enabling digital twins and what kind of challenges and solutions there have been. So go ahead.
Yes,
Roope.
thank you, Maarit, and thank you, Jarkko, for a very nice, good presentation and very good examples of how we can use information in digital twins. My name is Rodrigo Coloma, and I work as a planner or data manager in the spatial information unit of the city of Tampere. And my title here is challenges and solutions with a question mark, because unfortunately I think I'm going to put the feet on the ground and see that why we aren't in this digital twin world already. Why the planning process are like dragging, and the information doesn't flow that we could use it easily in digital twins. So I work in the data coordinator, more like 3D data. So the presentation will be of a point of view of this BIM and 3D point of view. So I hope you see the presentation, and
Yes, it's visible.
okay. And we go to the content. So a little bit of spatial information unit where I am. So we laser scan and we make aerial photographic information and produce data from that product. So that's the initial data that we try to provide to like building information modeling based planning could be occur. So this city planning will plan also in 3D, that it's more visual information to use in project city models and to be used in the future in digital twins. So we go to the current process, and we'll see what challenges we have, and then we go to progress and see a few game platform experiments and the development of this point of view. So yes, we give away this 3D data of buildings and terrains and city environment, how it looks like now, and we have also like GIS data and borders where we give information about the buildings and the environments and land use and traffic and quite a lot of information. So a wider range of type of data, and also download portals when where you can download this like file type of information. Also we have interfaces that you can connect information, and we have been doing that for a long time now, and we have few experiences of using those interfaces also in models. But first thing, I have like tried to make this concept and make very easily to understand this concept, because if I can understand it, I know that you are going to understand it. But if we think all this data that also Jarkko showed as in the earlier presentation, and name it like an infrastructure asset management, but we can understand that it's coming from different databases, and it is like BIM or SIM or IM type of information, and it's GIS and CAD information. It's information from the traffic and from the land use and from every areas of the city planning and national level, like information of building and so on. So if we see that we can manage this kind of digital data of the infrastructure assets, it will be more easily to have a digital twin, to create digital twin. They are very close to one each other. So if we can see this concept, we can dive to the next dia to see what are the challenges of this like information management and flow to the digital twins. So we go to the current process of the city planning. My work consists lots of being in project and try to act inside the project to make the information like management and flow. And I have few pictures here that try to represent the different areas of planning. It could be concerned to land use and area planning, green areas, or rain waters studies, or traffic street like planning, or pipes and electricity, or different kind of type of the city plan, like production lines. So all of these production lines have their own process, and the current way or the old way that we have is that the final products of this process are PDF files. So the decision makers and where they approve and accept the plannings are approved by PDF files. So you imagine if these are the production lines, when we need the information flow go to like database, infrastructure, asset management, all this information, it's very difficult. But we can see the change that are occurring and coming bit by bit. So the digital twins are mostly made like they are also like a snapshot, because they are not connect to the straight to the source of the information. So they are like a snapshot. It's like a digital twin, but static digital twin. So what we want is to make this information flow to databases and to digital twin be as close as it can be to the infrastructure asset management database. So one of the challenges and the improves that we are seeing is that the requirements for acquire and order and buy information and planning are like changing, and we have those better tools to order data and to order planning that we can use in many ways. They are not only PDF files, but it's the information behind those files, and also we can see that the tools are going forward. They are development better tools that we can see in the early presentation also, and that the knowledge of this is spreading, and it's coming also to every places in the city. So one of the thing that is close to my job in the projects are doing data management to the project. So we have a project data management plan that that tell us that with which requirements we are going to use to order planning and order data, and we have to have a project data bank where all the data is going, and we have like project city models that show how the planning are going on, and it's a very like analog or mechanic type of data management, but it have to done to do that the information flows through the whole cycle of the project. So in the end, it looks like more like this, that we provide initial data, the different production lines give planning data, and that's how it's the update. It's all updating information, and the visual product of that is city models, not yet more intelligent digital twins. Digital twins is more like that we can ask the city models things, and we can get straight answers from that. So the project city models looks, they are a wide range of city models of the project when it's depend of the phase of the or stage of the planning. So this is like a park and city, some city area, and there's of bridges and underground data of the planning, and there's street planning. So we have seen that when we try to drag this information in this model type of visual type of city model, it's always like a little bit late than the actual planning. The planning goes much faster in the own databases and own like companies program and own computers than the city model comes a little bit late, but it's improving all the time. And it's this data management concept, it's all a little bit like coming more and more to the projects. So what we have done then when we gather all the data, we have this 3D cave here in Tampere, and we have make like a city center like this basic level digital twins, and we have been there with citizens and decision makers and planners, and we have like competitions, planning competition. Then we can see there these different kind of solutions or propositions, and the judge are there, and they can see not only PDF files but like be surrounded or inside this proposition of the competition ideas. So this has been like a huge this kind of advance in using these models in the planning process. Well, here is a picture of one game platform work that we used before the tram was made, and we asked the people to jump to the train, to the tram, and experience how it's going to be in the city center, go with the tram, and to ask them that which color that you want the tram to be, and we use this virtual reality for that. Then we have made games of for planning to the citizens, that what kind of a park they would like to be in city center. And this is a picture of a digital twin of Hervanta that we're gonna see a presentation of that a little later. But this is the newest project that we have, very interesting. And we also have like company's own tools that we put the data there, and we can manage this project models there in the project. And then we have, for example, done this application to phones where we ask the citizens what kind of investment they would like that the city do in their home area, and also a little bit of augmented reality in Hiedenranta, and with different tools. So a little bit how we see that the future is going to fall. This is like we hope so, that these is different areas of the city planning, the production of line, we can see that the laws are changing slowly. The final product is not a map maybe anymore. It's going to be more intelligent information, like in the general area planning. We can see in Tampere they plan this information that go to the database, and maybe in the near future it's going to be the same in the local area planning. And we hope that the planning of these different infrastructural like areas is going to fall to the same, that the information flow can occur, and we could have this like updated infrastructure asset management. In Finnish they say infraomaisuuden hallinta, but it's of course a wide range of different kind of information. So if the process goes to make this more intelligent type of information, we hope so that in the future the process are around this databases. So the database will look like more like digital twin. So if we need to make PDF, we can print out a map or PDF or 3D model, or use it in different devices, or most important, we can ask the digital twin for solution and to help us to make analysis of different kind of things, like the solar that we see in the earlier presentation of wind or noise, and more easily to use in gaming platform, and then we go more further to digital twin. So yes, that was my presentation. Thank you.
Thank you, Rodrigo. I don't see questions online, but I could ask one question. As we have made collaboration between now Stardust and also your organization, how do you see is there how the project in the future could help in this future target of yours or your future vision, and the collaboration? What could EU project, for example, could do to help?
Well, that's a good question. It comes to my mind that these experiments that we have done, it require the companies like own tools and knowledge, that they are so much more advanced that we are, and the final product usually is a product outside of the tools of the city have. So I wonder if we could, like in the future, make experiments or projects that develop our own tools that are like open source based solutions and tools, that the work does not like leave the house, but the work stays on these platforms that are open source.
Okay. Thank you, Roope. And next we will move to the company or business side. We will have Jarkko Männistö, Service Manager, and also specialist Nico Moreira from Citywise, and they will tell what digital twins tell us towards digital cities. Floor is yours, Jarkko and Nico.
Okay, thank you. Okay, those were really great presentation from Jarkko and Roope. So I just thinking that I'm just repeating those things, but maybe this presentation gives another angle what we have done in Hervanta area and how we are using game technologies to make digital twins. First of all, Citywise, we are building a sustainable and smart living environment, and we have nowadays 3 key sectors: infrastructure, building, and digital solutions, where I and Nico come from. I'm showing you the video, and in this video we can see how the real world and city environment transforms to 3D geometry and to visual window of data flows in digital twin. We don't live just a 3D environment, but at least in 3D plus environment, because our cities are dynamic and full of activity and mobility. We have people flows and traffic. Our environment is also more like 360 view. This video helps us to understand what happens in our built environment, where we live, and how digital services and solutions will change our behavior. Availability of data defines the context of digital twin and in digital world. And also we can find more dimensions than our 3D real world gives, like we can show present time, safety and security, economical, ecological, or even cultural sustainability. So our digital twin and digital environment gives us more dimensions than real world. And also digital twin is collaborative, smart, and alive because it's based on game technology. I don't go any deeper of digital twins because Jarkko already told what it is, but it's a virtual playground to manage, innovate, collaborate, simulate, analyze, and optimize project virtually. One of the key things is 3D environment and how we process it and manage it. We have a source data, we have an information management system, we publish it, and also we create 3D environment. And what is really important, and that we can put back that data to our information management system, or even create new source data based on 3D environments. Communication, collaboration, and interaction. Those are the key words that then we understand what happens our smart cities, and how we are creating and why we are creating visual digital twins. Our 3D environment is developing from the static environment to dynamic environment. We can use 3D city environment as a planning and design platform. We can use it to simulations, and most important thing, we can publish real-time data and also make analysis and forecasting. Digital twins offering many possible benefits, like it provides a big picture for city, disrupting the traditional siloed information flows and practices that focus into individual components and projects. Because we have a great demo after these slides, I don't go any deeper of these slides, but Nico will tell in a live demo how we can help urban development to use 3D data, how we can create understandable language and communication between different stakeholders, etc. And also, digital twins help smart cities. We can simulate 5G networks. We can create connection to IoT, or we can simulate autonomous public transportation, or smart lights, or air quality, or whatever we want to show. And also, digital asset management is really important, and I think that this will open in Nico's presentation more. And we have different scales in digital twins. We can discuss in city scale things, but we can also go more deeper, like building to inside buildings. We can publish HVAC machines data and use that like maintenance systems. But that was shortly in general what we are thinking about digital twins, and now let's go with Nico to real demo to Hervanta area.
Yeah, sure. Thanks, Jarkko. Hopefully my screen is visible. So if it is visible,
Yes,
we should
it's
be now
visible.
in Hervanta. Yeah. So here we have the basically everything coming together, what both Jarkkos have been saying and what Rodrigo said about the initial data that cities provide and collect. And all of this is basically now built from that kind of initial data. So from our perspective, the idea was to test the gamification aspects and simulation aspects of the possibilities of a digital twin in Hervanta, where we have a autonomous vehicle testing site that is feeding traffic into the public transportation system. And these tests were being conducted in the area, and therefore we created a digital twin for the area. The testing area can be made visible by choosing the base station's measurement for the wireless network in the test area. And these are measurements by VTT from that test site. And we can basically visualize it here, but then we can also bring in the simulation aspects. And the idea here was to have this kind of game engine utilized in a way that allow us to also give access to third parties to this data so that they could build their own sandboxed experiments, perhaps autonomous vehicle testing could be conducted here using this kind of source data or this kind of digital twin sandbox data, and they could simulate different algorithms and test them out in real-time applications here, because here we have dynamic real-time transportation, public transportation. We have trams and buses driving here, sending real-time data in to the game engine. And when we zoom in, we can see it better. So we have the tram driving there. I will disable the layer so you can see it better. So we have the public transportation ongoing here, buses driving, so on and so forth. We can click them and get the information, the line number, the bearing, the position of them, and so on and so forth. And basically, game engines allow this kind of interesting real-time simulation environments to be rapidly tested and produced. Here we can see a bus is coming to a bus stop, and the pink dot that you see in front of the bus is representing the data point that is coming through the API delivering the data for the bus. So then the bus is chasing this location point in 3D space. And this GPS data that is coming through, it is not in 3D geolocation. It is just basically two-dimensional map data. So what we are doing here is that we are augmenting, using the game engine, this data by supplying it 3D coordinate data using this city model as a basis. Then we can also engage into simulation aspects for the 5G network that is here. So we have the 5G base stations here, and we can calculate and simulate the radio wave propagation and how will this vegetation, public transportation, buildings, how will they affect the signal? And we can literally manipulate the base stations in the 3D environment and recalculate the effect, the propagation of the radio wave behavior in this dynamic environment, which is very cool because then you don't have to necessarily do expensive testing on site. You can simulate the effects, and once you're happy with the results, then you can go to on-site to perform those operations. And then what we can also do, of course, is pick a vehicle and go on site. I'm experiencing a little bit of network traffic here. My internet seems quite sluggish at the moment, so it can be that this image is maybe coming with a slight delay. I apologize for that if you have that kind of experience on your end, but I'm trying to display how we can basically drive with a simulated vehicle here, and this could be also the vehicle of the testing being conducted. I'm basically breaking the rules here, the traffic rules, but this gives a really good impression on what kind of people work here at Sitowise. Basically, what I can do is simulate the driving here in this environment, and this could be connected to an algorithm that is operating the simulated vehicle, and then could be used as a basis for testing for autonomous vehicle traffic. Then what we also tried, what was new, was this HD map data from city provided sources. So we connected the game engine to retrieve from a WFS service that the city has some data that can be used for HD map production So what we're doing is recreating that same data here in a game engine. And again, we are augmenting it by using the 3D geometry available for us here. So if you have 2D GIS data, it receives the height information as well as a result of the augmentation. So we can actually enrich data. And these data points are basically describing and updated from the WFS connection. We have it updated. So whenever the data is updated there on the servers, it will be updated here as well, because we are constantly refetching and redrawing this information here on a game engine environment. And so we have the traffic light information for traffic light junctions on the road. Then we have basically the functions of certain parts of the street, the road center lines, all kinds of information that are coming through from the WFS interface we can display here. And this was really interesting to us to test, because game engines don't readily ingest this type of data. So this was interesting test for us. And in this case, because we are basically recalculating, redrawing the data points here, this means that we can actually also, like I said, augment this data and allow us to do basically modifications of this data within the digital twin. And if we were to supply the modified data back, we could. And that's kind of interesting, where you would have this kind of dynamic back and forth exchange of information from a game engine, because game engines are highly dynamic environments and allow many kinds of simulation features. Now looking at the clock, it starts to look like my time is coming up. So just to make sure that we have time for questions. So if Marit would be so kind and if there are questions, read them out for me so I can provide answers, hopefully.
I don't see any questions from the chat, but thank you for the presentation. I have one question. How do you see that, what should be the next steps for the cities, as you have been working with several cities here in Finland and maybe also abroad, that in order to make the development of the digitalization or the digitalization work to progress, so what should we do next, or where should we concentrate in the cities? How do you see it?
Well, I see it that we need projects like Stardust and that basically foster an environment of experimentation and collaboration between the cities and stakeholders that are because most of these things that we do are still in a proof of concept level, and they would be ready to be used for construction projects and for the kinds of reasons that have been already outlined during this this interesting webinar. But the reality is that these need to become familiar and mainstream technologies, and that cannot occur before we have enough of this kind of organic collaborative network between business and cities and stakeholders together, and that we can spread the information out there by showing what can we do and what have we done, what have we learned, and keeping it open, because a lack of information or lack of experience usually is the main thing stopping this kind of projects from becoming mainstream and basically the norm. So therefore, cities are struggling to capitalize on the benefits of this kind of the use of this kind of technology in their processes.
Okay, thank you, Nico, and thank you also, Jarkko, for the nice presentation. And now in the program, we have a break, so we can a little bit stretch our legs and get some coffee. And we are a couple of minutes behind the schedule, but I think we could still keep 5 minutes break. So we will be back in 17 past. And after the break, there will be then Skanska and VTT coming to tell their projects. So 15-17. All right, it's time to continue. And next we will have Niklas Töyrylä and Valentin Velinov from Skanska. And they are going to tell about digital twin in the residential building.
Yes.
Floor is yours, guys.
Thank you, Marit. Just share our presentation. Here we go. So good day to everybody. Thank you for the really good presentations from both Jarkko, Roope, and Nico. Really interesting to see your insight and view into digital twins, as you're probably looking at it from a little different scope than we are. So we'll be looking into digital twins from a residential side. So specifically, the use case is revolving around the residential building and how digital twins can be utilized from use cases of different stakeholders. So me and my colleague Niklas will be digging into case Härmälärannan Sampo and actually like presenting what we did in our pilot projects and what kind of findings we found. So to introduce myself, my name is Valentin Velinov and I have been in Skanska for over 4 years and currently work as a development manager in our BIM and digital services unit. So mainly focusing on developing smart building concepts in collaboration with both our partners, but also clients. And Niklas, if you want to introduce yourself.
Yeah, and my name is Niklas Töyrylä. I work as a project manager in residential development here in Tampere region, and I've been part of the development of this pilot project, Härmälärannan Sampo. And it's nice to have attendees from other countries as well, so I started from the basics, and since not all of you may know where Tampere is located, so here's the Finnish map, and we circled Tampere in there, so it's located a bit under 200 kilometers north from Helsinki. And from the right side picture, you can see a map of Tampere, and our pilot project is located in southern Tampere in area called Härmäläranta, which is about 5 kilometers from the city center. And this is the visualization of the area. Härmäläranta is an old factory area with a lot of history, and over the past 20 years, it has transformed into modern and urban living area right next to Lake Pyhäjärvi. The area has good connections to city center and gets better with upcoming tram line. There's over 200,000 square meters in building right that offers homes for over 4,000 residents when the area is completed. And the pilot project Härmälärannan Sampo is one of our waterfront buildings and is marked with a circle in the picture. Maybe the next slide. Yep. And here's some more information about the project itself. So Härmälärannan Sampo has 7 floors, 40 apartments and guest room that offers extra space for residents' guests. The building was completed a bit over a year ago. The heating is produced by district heating, which is quite a traditional way here in Finland. And Tampereen sähkölaitos is a forerunner in terms of using renewable energy while producing district heating. And the heat is delivered to apartments by floor heating system. Every apartment has their own ventilation system and ventilator, and the ventilator can also produce cooler air to apartment, and it also has a good recovery system, heat recovery system. And as you can see from the picture on the top right, these features may make the machine itself quite big and heavy, which make it quite hard to install in design way and also as installments. And on top of the building, we have solar panel systems that produces electricity to building itself, which means elevators, lights on the hallway, and the ventilators mentioned before. And the solar panel system is quite small in this case, as you can see in the picture. And since the building was completed, there was some legislation changes here in Finland that has made it possible to use the solar energy also in the apartments. And nowadays we can build much more bigger solar panel systems to the roofs. This entity, which includes heating, cooling, and ventilation, is controlled by automation system. The room level control panel is shown in the picture on the top left. And in apartment level, the residents can adjust the indoor conditions, as mentioned, the temperature and also the air condition in room level. And there's also a system built for building automation, which gives a bit bigger picture how the building operates. And by the automation system, we make basically sure that there's no heating and cooling going on at the same time, and the HVAC systems works the smartest way. Then if we go to the digital twin and a little bit of the background for it, Skanska has used BIM models since the start of the millennium. And nowadays it's a vital part of our design and also construction phases. In our newest residential buildings, we also have modern automation systems, and many parameters are measured around the building and apartments. And this information is used to help us solve possible problems with the buildings and just to make sure it operates as it should. There's also room for improvement to utilize these features after the handover phase more efficiently. For example, as mentioned before, in maintenance, but also in customer service and energy optimization. And we see digital twin as one good tool for this and started to study them a bit more with this pilot project. And next, Valentin will tell you a bit more about the goals and scopes and maybe give a small demonstration of our digital twin.
Yes, thank you, Niklas. So digital twins, we have been working with them also for years now, but most of our use cases are based on commercial property needs. So residential buildings, let's say they're a new frontier for us. And this is why one of our goals was to basically get a deeper understanding of what are the indoor air quality circumstances in apartments. We know we can get the data out, but it's usually a point solution. In order to understand these really drastic phenomenons, we actually have to somehow smartly visualize the data. So visualization was a key part of our pilot project and how to get the understanding. But also once the data is gathered and we can understand the phenomena, of course, we want to optimize the systems. So in these terms, like a smart apartment from our standpoint is that the indoor air conditions are as stable as possible. But a lot of things happen in the sophisticated and very complex systems behind the product. So how can we actually, by getting a grasp of how the building is working, how can we optimize the back-end system of the building? Then, as I told you, we're also seeking to investigate how the digital twin can be utilized for different stakeholder needs. So in this case, we're talking about, well, in-house customers, as we have responsibilities in the warranty phase. Of course, there's the residents themselves and apartment owners. Thirdly, there is the building manager, so the person responsible for operating the building technically. And in Finland, usually we have also a housing company, like a governed housing company, who is basically responsible for upkeeping the building. So we were trying to identify different use cases from all these stakeholder views, and also experimenting how can we basically commercialize and offer the digital twin as a solution and a service to the apartment owners. And how we conducted this pilot, well, it was basically three-staged. So first, we created these digital twins out of IFC models, which were produced during the design phase, and connected the dots. So visualized indoor air quality data we gathered from the building automation system. Secondly, we enriched them with product and material information. To that, I'll deep dive for a little later. And third, developing the services. So what kind of control room views different stakeholders need, what kind of reports they should be able to print out of the system, and also analytical tools. So basically crunching the data and figuring out these phenomena. And I have prepared a small demo for you. For basically data privacy reasons, I wasn't able to show it to you live, but this is an up-running system which we currently provide to the apartment owners. So I have anonymized the data. And we have had a partner, Polku Innovations, who has helped us out with this technical solution. So this is basically the dashboard view of the digital twin. And here we can see the different data levels. So we had temperature, humidity, water consumption. There's also dew point and heating valve positions. And this is now basically visualized in a 2D level. So by quick grasp, you can see the real-time data currently going on. But of course, as it's a digital twin, we have a 3D view of it as well. So here we have brought the IFC model, which is basically the architectural model, and utilized the spaces from them and linked the data to the apartments or the rooms themselves. And we're utilizing only the architectural model, but of course this supports basically an EFC type. And well, real-time data, of course, it has its purposes, but we're more interested in bigger trends. So seeking to historical values over a longer period of time in order to analyze what is really happening and how stable the conditions actually are. So here's a representation of just one apartment of basically all the data values we have on a 2-week schedule, and see if there's some anomalies we have to react to. But looking at the apartment level isn't enough. So of course we can compound the data into basically evaluating all the apartments at once. So here's an example where on top we have the outdoor temperature for this period of time and how the temperature reacted in the apartments themselves. So what we're looking for is that there's no big spikes, so it stays as steady as possible. And we can, of course, define ourselves what kind of rules and visualizations we want to alter. And here is a representation of how we can reach the same spaces with additional documents. So this is the product and material documents, which are in a PDF file, because this is the use case they actually wanted. We also investigated that we'll populate the objects themselves with the data, but studies show that that probably wasn't the most efficient way to operate the digital twin. And basically, this is just one data source. Of course, there are a lot of more possibilities. So this supports basically all kinds of document files there are. Niklas, would you want to give us an insight of how the stakeholders were involved in this process and what kind of findings we've had?
Yes. Maybe as mentioned a little bit before, is that Skanska is not the main stakeholder in a way for the digital twin or the main user for it, but the housing company itself might be the one getting the most advantage out of it. And so we interviewed a few of the key stakeholders regarding the operations of the building and upkeeping of the building. the first thing we did was, of course, to study the internal stakeholders inside Skanska. As Valentin mentioned before, we have all the material information of all apartments in one place, and then we have the, as you can say, the delivery documents in one space, and so we tried to figure out how to bring all this information into one platform. We also presented the features to the residents before they moved in, and it wasn't that big of a surprise that it raised only a little conversation. The conversation showed that there seems to be some cool additions to some of the people, but there wasn't that clear or big demand for this kind of tool for each resident. We also had a few discussions with the building manager regarding the advantage of the digital twin. And since the building management is highly competitive field of business, and the margins between the companies and is very small, and housing companies are very eager to change the building manager if they get cheaper offer from somewhere else. So investing and committing to new platform wasn't, the building managers weren't so keen into it. And since you are basically selling time using new features with not that clear advantage at this point, raises some doubts. The building managers, they saw big potential in collecting data from, for example, different renovations inside the apartments or for the building itself, and that was a good thing that came up in the conversations. But the biggest challenge was the use of extra time and money, and maybe the difficulties to link different platforms together, because the building management companies, they also have their own operating platforms. But the biggest advantage we're seeing within the housing companies government, as I said earlier, the digital twin gives real-time and transparent information of the functionalities of the building, and it enables the government to take actions if needed related to the building, maybe the management or the maintenance. As Valentin showed before, there were some red apartments, so something needs to be done to make them green again. So it could be a tool to guide the building management or the building maintenance. So maybe as a conclusion to this, the stakeholder what could benefit the most out of the digital twin is the housing company's government, and maybe by that it should be the one who's basically the owner of this digital twin and responsible for the updates and all needed. It could be shared to other parties such as building management and building maintenance to ease out their work, but the owner should be the housing company's government. And I think it's time for final words. So maybe Valentin, you will give us some of your thoughts on potential of digital twins.
Yes, just to sum up, I'm looking at the clock, we're running out of time. So if we look at the bigger picture, well, digital handover is a term which is a hot potato currently in the field. And of course, as a contractor, we're really interested in this concept. And I see a really close linkage to digital twins, because the basic idea is that all the basic information we gather from the development stage to the handover phase, we can submit it to the client in a more, let's say, like smarter way. So not just dump him the materials, but better consolidate it into some kind of a service. So additional materials can be, for example, different documentations, 360 pictures, or even like maintenance service manuals and warranty documents, which are linked to the materials and products. And of course, commercialization. So digital twin is valuable when it is upkept, but a platform in itself doesn't solve it. So we need different kinds of services, service providers who can actually make a business out of it. And here is just a concept we have actually been developing with a partner. So the end service may look like a chatbot, and we offer the upkeep of the BIM basically as a service to the client. So if there's a change that happens in the building, the operator service is basically responsible for upkeeping the digital twin. So on a bigger level, we can think of a digital twin basically as a ledger. So even though the stakeholders around the building premises change, the ledger is always stays intact. But yes, we're running out of time, so thank you very much for your interest, and we're open for questions.
Thank you. And there is Ulrika is asking, is it possible to adapt, for example, ventilation and temperature in different parts or room of the building, depending to how many people there are or will be in the different parts or rooms?
I think I can answer this one. Yeah. So yes, it is possible, and by using, for example, CO2 sensors, the system itself can analyze how many people there are in the room, if there are changes in the exhaust air, and it can be optimized to lower the temperature and increase the ventilation. The problem, in a way, is that if we are making too many things automated, it may cause some problems. For example, in a way, if the CO2 starts to increase and we increase the ventilation as well, there might be, I don't know the exact word, but the air is flowing too fast, which can make the indoor climate not so good in a way, the way you feel it. It might feel a bit windy or cold through that way. So the way we solved this problem in this building was that there is one button which you press on the wall panel, and it increases the ventilation system and lowers the temperature a bit. And I think it was called some kind of party mode. So when you're having more people over, you can just press the button and it does it for, I think it was like 3 or 4 hours, and then it goes back to the normal stage.
And to continue, if you look to continue Niklas's reply, if you want predictiveness to it, well, usually we also connect the room reservation service. So we basically have some kind of a knowledge of when and how many people are coming to the room, because we basically have to kick up the ventilation before they actually arrive.
Okay. Thank you, Ulrika, for the question, and thank you, Niklas and Valentin, for the presentation. And then last but not least, we will have Kalevi Piira from Stardust partner VTT to tell about the utilizing electricity data in the digital twin. Please, Kalevi.
Yes, thank you. So my presentation is only related building information model and related electricity data. Even we could do much more with that. So first, one definition related digital twin. Jarkko has given a good definition, but I use this one, which Open Geospatial Consortium John Lieberman defines. So that digital twin very similar to the is so that the digital twin looks like the same as real, and it behaves the same as real, but it's not real. And in our contents, it means that we have real building, which is in this case Tampere valtatie 30. I will use in next slide is the HTV 30 term here which describe this building complex. And then we have digital twin, which has two features. It behaves the same as the real building using neural network-based artificial machine learning models and also energy calculation models. The basic idea here is that those digital twin gives same value as measurements. And then we can use it for many different purposes like optimization, forecasting, fault detection, and this kind of predictive maintenance issue. But here we have only used it for prediction related issue. And then it looks like the same, and then we have this kind of building information model where we connect those electricity data. And it has done so that we have in this building complex, we have 192 electricity meters which are connected to VTT's data platform through Schneider systems. And then we have a building model which we have uploaded to BIM server. And then we have weather data and weather forecast related data. And these data is online connected both in that digital twin which look like the real and which behaves like a real from energy point of view. And we are in energy side where we have electricity district heating and district cooling, but we in this presentation we are concentrating in electricity issues. So first we look at this looks like the same. Of course it's not really looks very same, but here is the BIM model of this model which we have, and we can present different kind of information in our BIM model. It can be if we have values, for example, temperature, air quality issues, some analyzed cost related issue or energy efficiency related issue. And the basic idea is that we can study using this model that in which time some value has been above or under some limit values or where conditions are good and so on. It makes us rather much different kind of issues to study. So those values which we have to study, we can use meter related information, sensor level information to connect space, for example, in this case in BIM model. And I will show one very short online demo here. So here is that digital twin of that Tampere valtatie 30, and we can, for example, study where the maximum average or minimum value has been, for example, I take more less contrast. Okay, this is okay. So we can study in which part of the building the values have been between 172 kilowatts and or this part of the building has used most energy and so on. And we can select different times scale where to see those values which are here. And of course, this kind of BIM model, as you see when I move cursor here in this part of the picture, we can see what base is there, and we can connect all that kind of information which is available from facility management system and that kind of systems, because we know that BIM related GUID, so we can connect using this kind of information. And of course, it's very flexible. We can put it, I'm not sure how robust this see through net interface, but it's very easy to see, and we can use very many different kind of information here, which is available, also analyzed information. But okay, I have so little time left, so that I continue to next slides. So here is the other digital twin. This is how the behaves the same, like the same. So we use the different kind of approach to make that kind of digital twins, which give same values as measurement. So first was this kind of Sarima models, and then neural network. This is more analytic methods, and then feed-forward related neural networks and gated recurrent units grew related models, and this long short-term memory LSTM models, which I'm presentation here for electricity. And for building sites, we discuss test different kind of models. One is using simulator models for learning those building parameters by data. One was energy signature method, which was described in this EN standard. Then was statistical machine learning models, and also this feed-forward related neural network models. And here is examples of those, how near we are with predicted value and measured value from energy consumption. And here is also more related, and there is district heating related in. Very short online demo. So here is, for example, electricity related data. So if I zoom here, we can see how well those fits. For example, if I checked, here is now only those measured value. Now there is also a predicted value. Okay, I take here some other slides. So this can see that this model is rather good for predicting those electricity related consumption. From district heating consumption, prediction is not so good, as you can see here. If we look at the prediction and measured, we started to predict at this time. This is only those data which we use for learn this model, but okay, that was that one. I skipped those issues. So how can we use this, which is not yet implemented? It's not implemented in Stardust project. We could optimize this building energy usage using these kind of models. We could use those for fault detection and fault diagnosis related issue and predictive maintenance related issue, and those smart grid related use cases and related virtual power plant use cases. Okay, and very shortly, I was asked only also say some word about COVID-related effects on this consumption. because we have all those data. So I will demonstrate also that very shortly. So we have here those electricity meters. For example, here we see that COVID started in this time. So and this is related office and also common space. So we see that the electricity consumption was lower after COVID, and it has grown a little bit, and so on. And if I look some other data here, this is more related air handling units and also water chiller related consumption. So there is not so big difference here before COVID and after COVID issue. This is data center related data. So we see that there is little change here, but this is because it's growing all the time because those capacity is growing. And then we have also some offices and data center related issue. This is same effect than offices earlier, and then here, okay. This is also data center related issue, some growing, and in last days very big growing. So I think my time is now used. So have some questions, so please.
Thank you, Kalevi, for the presentation and very scientific. Really, like VTT work is always. You showed these options to go further with this model. So is there already new project starting, or is there like these are the ideas that could be used then with the new planned project?
Yeah, this is only ideas which we are doing in some other project because those issues were not in this Stardust project, but there is different buildings in those project.
Okay, so the work is continuing.
Yeah.
With other projects. That's great.
Yeah, we have typically in different digital twins connected those values which we have much more information. In this case, there is typically not very much electricity submeters in buildings. This is an exception, but typically there is much temperature and CO2 and this kind of thermal comfort related issue, and which we are showing in these digital twins.
Yeah, and like Skanska is also one partner in Stardust, isn't it? So that there is also data coming from these targets or the pilot target from Härmälänranta to VTT also.
Yeah, we have same kind of feature there. One is also that kind of feature that we can use those buildings as thermal storages. It can expect all those this. So how much thermal storages can be used from structures, for example, into tomorrow district heating, but of course there is no demand response signal coming. So, but this we have done in Härmälänranta case.
Okay. Thank you. And this was actually our last presentation. So I would like to thank you, all the participants, of course, and then also our speakers. Thank you so much for your time and interest, and virtual applause to all of our presenters. And we are now in end of our webinar. This webinar was recorded, like mentioned in the beginning, so it will be, we will inform when it's available, and you can see more information about Stardust project in this web page I show you, or it is here, so stardustproject.eu. And that's it for this afternoon. Thank you, and have a nice rest of the day. Bye-bye.